Onchocerciasis is actually an African disease. More than 99% of all cases actually occur in sub-Saharan Africa. It's a disease which causes river blindness. I think it's best known for that. Actually, if you're at the WHO in Geneva, at the entrance is a statue of a little boy guiding an elderly person with a stick, because this person has river blindness and is blind. So it's a very stigmatizing disease. It's very severe. It's caused by a parasitic worm called Onchocerca volvulus, which again is transmitted by black flies, so similium flies. So you get it by the bite of one of these flies. For onchocerciasis at the moment, there are about 120 million people at risk. Of these, about 12 to 15 million actually have the disease. And of these, again, approximately 1 million are blind or have a severe eye affection. So onchocerciasis occurs mainly in West Africa, in Central Africa regions. There's been a lot of effort in reducing onchocerciasis, a lot of success actually, through mass drug administration, through mass treatment of large populations. These similium black flies, they breed, it's very interesting, they breed in flowing water. So they have their nests where the larvae or the eggs are laid, little cones which are sort of in the stream of a river. And then these flies hatch and they sting or bite a human. And because this parasitic worm is in the skin, so it leads to a skin disease, which is very itchy and causes different manifestations in the skin, they pick up the worm and then transmit it again to other people. What is important there is that obviously the closer you are to a river, which has these black flies, the more likely you are to get the disease. And actually, the black fly is not very efficient in transmitting it. It needs to bite a couple of times before it actually transmits the worm. So people who are at risk are obviously people who go to the water areas often, who live nearby to a river, in a valley, for example. So there's usually sort of patches or hotspots where this occurs, corresponding to the range of the similium black flies. Onchocerciasis is actually a skin disease. So after you get bitten by a similium black fly, the worm is transmitted into the skin, and you get a skin infestation of this parasitic worm throughout the whole body, which leads to scratching, which leads to thickening of the skin. You get lumps. Within these lumps are adult worms, which produce what you call microfilariae. So they're very small larval stages of worms, which disseminate further through the body and infect the skin and other tissues. The scratching and the infection of the skin really changes the skin, so it's a stigmatizing disease. There are terms like leopard skin because of dyspigmentation, the patches which look like leopard skin patches, or elephant skin because of the thickening of the skin, or lizard skin because you get scaly patches. So all these terms have been used for onchocerciasis. Now the problem is the skin which is close to the eyes can also be affected, and these microfilariae can actually go into the eyes and then sort of create an inflammation in the cornea, at the outer edge of your eyes, which can lead to an inflammation, which leads to scarring, and then as this progresses untreated, can lead to blindness. So this is a skin disease, dissemination, leading to blindness ultimately. Before I actually explain this, you need to know that there are other worm-like diseases or similar diseases which often occur in the same region and actually have the same sort of pattern. They produce a lot of microfilariae or small larvae in the body, and they have different treatment strategies. So if you have one of these diseases is called loa loa. So if you have loa loa and onchocerciasis, you need to be careful to not treat loa loa first, because the drug to treat loa loa would kill all your microfilariae at once and create a massive inflammatory response, which could kill you even, can be very, very severe, which could cause blindness because of the inflammation. So you need to be aware of that. That's just one important thing to consider. But to treat, you can treat adult worms first. So there's an antibiotic, which is actually used for bacteria and not for worms, which kills an endosymbiont in these worms. So it's a bacterium which lives within the worm. This is a really nice story because it's an endosymbiont. The worm needs this bacterium, and if you kill the bacterium, then a lot of the worms die as well, about 50%. But what is important is that all the female worms, once these bacteria are dead, become infertile. So they will not lay eggs. So they won't lay these larvae, which cause the disease. So pre-treating with doxycycline, this antibiotic, actually already lowers the burden, gives you a much better fundament for then treating properly with ivermectin. And ivermectin is the hallmark treatment, will kill off all the microfilariae, and only then would you then treat Loa Loa with the other drug. It's a vector-borne disease, so you need to protect yourself from the vector. You need to stay away from rivers if you know this is a hotspot area. Bed nets are used. And here it's actually interesting to go into the prevention control program strategies which have been employed successfully, as I said earlier. There have been mass insecticide treatment strategies. So, for example, in the 70s, planes would fly over these river areas and spray large-scale insecticides to kill the larvae and the insects. In the 90s, then, ivermectin as a treatment modality came on top of that, so both insecticide and treatment, which really reduced transmission because the insects would pick it up from humans who are infected. And then in around 2000, there was an African program for onchocerciasis control where the communities had ivermectin and distributed ivermectin within a community, sort of large-scale targeted distribution. It was very effective. This went on to about 2015. For example, in 2015, in the last year of this African program, there were over 150 million people treated in a year. So it's very large scale, it's a logistic challenge. And because it was so successful now, since 2015, they've gone into the end game, into the elimination strategy. So now targeting countries or foci of high parasite density or high caseload with this treatment strategy approach to try and reduce those last pockets of disease. I think most of the challenges have actually been addressed because they've had really successful strategy. There's been a big reduction in the disease burden. However, the diagnostics remain a problem. The more you approach elimination of a disease, the more difficult it becomes to find actual cases because you have more people who don't have the disease, who could have it but don't have it. So in order to have a good surveillance in place to detect the last cases, which you need to target, you need good diagnostics. And this is a weakness in onchocerciasis because there's no really good diagnostics. You still have to take skin snips and look for the parasite under a microscope. There is a rapid diagnostic test available, which looks at IgG antibodies, which is now increasingly being used. But obviously it's got limitations as well, so it's not the ideal tool for going into this end game of eradicating or eliminating onchocerciasis. So this, I think, is one of the important issues to address in the future. Doxycycline, ivermectin are the two major ones. Ivermectin works really well, but there is another drug which is being evaluated, which is called moxivectin, which actually clears the parasite almost a bit better than ivermectin. But there's always a risk because the quicker you clear the parasite, the more the risk is for this inflammatory response. So it's a give and take, but there are still trials underway for that. And in terms of vaccine, there is a vaccine for cattle, but there is no vaccine for humans. The vaccine in cattle is based on inducing antibodies, and an antibody response, and seems to work pretty well. So I think there is hope for developing a human vaccine, and I think this is one of the major targets for future research in onchocerciasis. The research at the moment is not so much going into basic infection biology, although it's very interesting to look at the immune response in these nodules and the modulation of the immune response. So that's another theme, because these worms actually downregulate our immune response against them. Very interesting. But that sort of research is very difficult to get funding for. I think all the funding at the moment is now going all into eliminating the disease and just basically, employ or manage these large-scale mass drug administrative approaches. And I think that's where the money is going at the moment. So it'll be quite tricky to get big funding for pathophysiological or vaccine development issues at the moment. Yeah.